This is day 11 of Advent of Code 2024 Done and Go, and this challenge is called Plutonian Pebbles. The ancient civilization on Pluto was known for its ability to manipulate space-time, and while the historians explored their infinite corridors, you have noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on a stone changes, other times a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 0, it is replaced by a stone engraved with the number 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the left stone, and the right half of the digits are engraved on the new right stone. The new numbers don't keep extra leading zeros, so 1, 0, 0, 0 would become 10 and 0. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. No matter how the stones change, their order is preserved, and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take a note of the number engraved on each stone in the line, the puzzle input. So if you have an arrangement of 5 stones engraved with the numbers such as this, and you blink once, 0 becomes 1. 1, which has an odd number of digits, is multiplied by 2024, so it becomes 2024. 10 has an even amount of digits, so it's split into 1 followed by 0. 99 has an even amount, so split into 9 and 9. Then 909 is replaced by a stone marked with this long number. So after blinking once, your 5 stones would become an arrangement of 7 stones engraved with these numbers. So here's a longer example. We have these. This is multiplied, this is split. Now this gets split, and these get multiplied, and so on. So in this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have 55,000 stones. How many stones will you have after blinking 25 times? Okay, that sounds like an interesting challenge, so let's get started. Actually, I should go back here and check the input as to what this looks like. Okay, so it's just numbers on a line like that. So we don't need the input to be like this. We don't need this. It would instead be strings.field if it comes up, and then just the input inside of it. So this will get all the... Oh, that's why I wasn't coming up, because I hadn't imported it yet. We'll call this... call this string nums, just so we have something. But we'll create stones, which is equal to an array of ints, and we'll initialize that as nothing. So now we need to go through all the string numbers and then convert to integers. So for stone in range string numbers, num is equal to string conv dot toy, and that will be stone. And then we do stones dot append, stones equals append num. And is there something wrong with this? I need to do this. There we go. So we've now got all of our stones as numbers, and what we need to do for I equals 0, I is less than 25, I plus plus. Now what we need to do here, actually we should probably turn this into a function. So we'll put that up here, and so what is it that we are doing? So blinking, so we'll process blink, and this will be a function which takes in the stones, and this will return the stones. We'll return a new order of stones. So we'll do new stones, which is equal to int like this. We'll then iterate over the stones in the stone. So for stone in range stones, we then need to look at the number and figure out what we're adding to this. So if stone is equal to 0, then it turns to 1. So new stones equals append 1. And then the next condition is if the amount of digits is even. So else if, so would convert it back to a string. So string conv dot, let's see, what are we looking for? What are you? Okay, it takes an int, returns string. That I saw was a toy but rearranged. I thought maybe that's it. Cool. So we take in this stone, We need to then check the length of it, and modulus 2 equals 0. Then what we are doing is we're doing num string again equal to this. We then need to do left, and what would left be? Left will be num string, and it would be from the start up to, actually we'll do half is equal to length of num string divided by 2, so up to half, then right will be half onwards, and then it will be, actually we'll convert this to an integer first, and then we can just append it directly to the new stones. So this will be new stones equals append, and this will be left, right. And I forgot to count for the error that's also being returned. So we've done that. Now for the final condition, which is new stones append, and that is stone times 224. So we do that. Now we need to return the new stones. And then inside of here, we've got this, and we will do stones is equal to process blink stones. Then we'll do output is equal to length of stones, and then do that. So let's run it and see what we get. We got 193899. Let's see if that's correct. And it was correct. So now let's go on to part 2. The historians sure are taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 times? Okay, so we'll start off with copying all this, and I'm going to assume we're meant to do something to make it more efficient, but I am just going to make this 75 and see what happens. Okay, this is taking so long, so I'm going to stop it if possible. Okay, so it took me a little while to stop it, but during this time I was thinking about how it works. So in the original challenge, I was talking about how it maintains its order, but we don't actually ever use this order. We are purely looking at the amount of stones in total. So we don't actually need a list to hold every single stone. We could instead just use a map to hold the value of the stone, and that holds a count of the amount of stones we have of that number. So we would go through, like, let's say, so in this example there are 1, 2, 3, 4 stones with the number 2 on it. In this map would have the number 2, and it would hold a count of 4, and the outcome of 2 is that it gets multiplied by 2024, so 4048. So instead of having to process this one stone 4 times, we would process it once, and then in the new map we'd put 4048 and a count of 4. Then 4048 is would have 4 of them. It's double, has an even amount of digits. We would then split it up, 40, 48, and put it into the map again, with 48 having a count of 4 and 40 having a count of 4 as well. So that would make things much more efficient. So that's how we will do this one. So because we're maintaining a map which we want to keep track of, we want to change how this works. I don't think we need a function anymore. So we'll get rid of this, and we will instead, actually, how are we going to do this? Okay, right, so up here we have stones. This will be map int to int. Oh, wait, I need to do map int with a count of int. So in here we will be doing stones num plus plus. So we've got our stones, we've got new stones, which will also be this. At the bottom here, we will do stones is equal to new stones, and yep, we're iterating over it like we should. Actually, we need to change this, so it'll be stone and count. So if stone is equal to 0, new stone 1 will equal count. Oh, not 4, count. If the length of stone is this, we do the exact same thing again, but now it is new stones left is equal to count, and then the exact same thing but now with right. And then for this one, new stones stone, actually stone times 2024 is equal to count. I think that's all that needs to be done. Yep, actually no, I need to change how the output is done. So now we need to do we need to get the values. So for this in stones, count plus equals, so output plus equals count. I forgot to do range stones. Output, that's not defined. Yes it is, you're defined there. Why aren't you working? Oh, I spelled it wrong, that's why. There we go. So the only way this works is because we do not care about the order. If we did care about the order, we would not be able to do this, but we just care about the total amount. So now let's run it. And we could have actually done this exact same code for the first part. Okay, that number is not right. Definitely not right. Where did we go wrong? Oh, so this is the problem. It should be plus equals. Because there's a possibility that there are already stones in the collection with the exact same number. And what we were doing is overriding it. So we actually just need to update it. Okay, now that should be correct. Oof. Well, that number sure makes it look like it's correct. So let's put it here and see if it is. And it was correct. So that is day 11 of Advent of Code 2024 Done and Go completed. If you like this video, make sure to like and subscribe.